Redeem Academy. Yo, what is up, Science Squirrels? Johnny here with Redeem Academy. I'm here to help you get the most out of your education while giving God the glory he deserves. Today, we are going to be going over the chemistry unit workbook. That is not to be confused with the chemistry unit notebook. So workbook videos just are for you to get help with the pages related to the lesson that you are on that day. So you can look at the bottom of the timeline of this video and you can scoot forward to the section that you need. So if you're on lesson 1, you can find workbook pages 1.1 through 1.4. If you're on lesson 7, you can find workbook pages 7.1 through 7.4. Just skip to the part that you need for today. All right, here's this bad boy with an extremely handsome science teacher on the cover. Here we go, 1.1. So circle it, pretty straightforward here. This is a liquid, and over here, what are these particles doing? What do these particles do? They wiggle. Matter where atoms slide past each other, that is a liquid. Nothing surprising for you to see here. Up to 1.2, got some labeling. The big gap here is empty space. All right, what's my symbol? Now here's something you need. You're gonna need a periodic table for this. In your curriculum, there is an insert of the periodic table that you can just stick into your workbook. You're gonna need this over and over again throughout the whole unit. So what's my symbol? Carbon. You're just gonna have to search through your periodic table to find carbon. He is number 6 right here. So you just look, see the symbol, see the name. In this case, we have the name, and so what are you supposed to put right here? You're supposed to put his symbol. Okay, we go find hydrogen. Hydrogen's right here. What's his name? What's his symbol? Hydrogen, H. And you just keep going, what's my symbol? And you put them for all of these atoms. Okay, 1.3, what's my name? Same thing in reverse. Some of the hard things are when you get to like Na, although I'd say finding a name from a symbol is probably easier, but Na is kind of a weird one. So Na does not stand for something that starts with N and A, it stands for sodium, okay? And like you learned about, some of them get their names from Latin. Okay, go down to the bottom of 1.3, circle the best answer. These are all very straightforward, but an example, that arrow is pointing at a 6. What is that 6 called? It's called the atomic number, A. Okay, go up to 1.4. Now this gets even more complicated, so I'm going to give you one of those 3 details, okay? So I gave you the name, oxygen. So now you got to go find the symbol. Here's oxygen. O is the symbol. And number of protons. So on oxygen, it has an 8 above it. That tells you the number of protons. So the atomic number tells you the number of protons. So now we come down to the number 6, and all I've got is the number 6. I don't know the symbol or the name, but if I know the number 6, then I know it's carbon, and its symbol is C. So symbol, C, name, carbon. All right, let's do one more. Sodium here. Now I have its name. Actually, we already did one like that. Let's go find a difficult one. There's nothing too difficult here, but we'll do Ca. And so Ca is for calcium. Calcium's number 20 over here on the periodic table. So 20 protons, Ca, calcium. Okay, and so I'm going to write calcium, Ca, and 20. You do the rest. Now, the bottom says John Dalton finished the sentence. So John Dalton was a British scientist who discovered that each, spoiler alert, the answer is element. All right, that's 1.1 through 1.4. We're going to move on to 2.1. Okay, 2.1 review. This is a picture of an atom. Okay, down below, we've got matching. The number that tells you how many molecules is called a coefficient. That's K right here. Okay, up to 2.2, circle the best answer. This funny thing that kind of looks like a hammock or something is a sugar molecule. You're going to have that down by the end of the unit. Okay, over to 2.3. All right, this needs some teaching. Okay, so I just went back and colored these real quick so that this is maybe easier for you to understand. So each one of these is a water molecule. There's 5 of them, so I put a big 5 in front. That means how many molecules, and then I write H2O. Okay, now when I'm trying to count how many atoms there are, I'm asking you the question, how many hydrogens are there? There's 2 hydrogens in each molecule. These 2 white ears on Mickey Mouse here are hydrogens. And so I'm saying 5 H2Os. I'm saying there's 5 molecules. Each molecule has 2 hydrogens. The trick here is to go 5 times 2 is 10. There are 10 hydrogens total. I could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the trick is just to go 5 times 2 is 10. Now, when I ask how many oxygens are there, the red atoms are oxygens. So I can see by counting there's 5, or the trick is just to go 5 times 1. It's like there's an invisible 1 here. And we just don't write that 1 because it's redundant to do that. So 5 times 1 is 5 oxygens. Now when I ask how many atoms there are, it's like I'm saying, if I were to count every marble, how many atoms are there? And so if I were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The other trick is to go, well, there's 10 of these and 5 of those. Or I could go 2 plus 1, that's 3 times 5, or 10 plus 5, 15. And then how many molecules are there? This big 5 in front tells me there's 5 molecules. Okay, now that's a lot coming at you all at once. You're going to get a lot of practice of this in the next 2 pages. Okay, it'll be very similar for this one. 1, 2, 3, 4, 5, 6, 7, 8 molecules of water. So you're going to have to write that here. Okay, but now we're going to salt, NaCl. So remember that this is Na and this is Cl. So how would I write this as a chemical formula? I would write 3 NaCl. Okay, and so how many sodiums is that? Well, remember, it's like there's an invisible 1 here. So I could go and count them all, or I could just go 3 times 1, 3 sodiums. Okay, remember that sodium is Na. And then 3 times 1 Cl, it's like there's 3 chlorines. When I say how many atoms, it's like I'm saying, oh, well, 3 and 3, or I could count all those marbles. There's 6 atoms. How many molecules? There's a big 3 in front, 3 molecules. Okay, now I've got a few problems like this that have it right in front of you, but then you're going to get over here and you're going to have to do it without seeing the atoms. So make sure you get good at this. Okay, now I've got 2 sugar molecules. These are big molecules. Okay, you could count them. Okay, I've colored them here so you can see. But the chemical formula here is C6H12O6. Now this is a very important molecule to life, but there's 2 of them, so I'm going to put a big 2 in front. So that's 2 C6H12O6. So how many carbons? 2 times 6, 12. How many hydrogens? 2 times 12, 24. How many oxygens? 2 times 6 is 12. And then the best way to do this really is just to add them up. That's 48. Okay, and how many molecules is that? That's the big 2 in front. There's 2 molecules there. All right, now you still have a lot more practice to do. You should go back and do these first, but also a whole bunch more practice over here. So I'm going to do 2 more of these for you. I hope you're starting to pick this up. Students in the classroom, they usually want to stop paying attention to me. They want to just go do it themselves. Go do that if you can. Okay, here's 3 C6H12O6. So how many carbons? 3 times 6, 18. How many hydrogens? 3 times 12, 36. How many oxygens? 3 times 6, 18. 18 plus 18 is 36. 36 plus 36, 72. 72 atoms. How many molecules? Only 3 molecules contain 72 atoms. All right, one more I'm going to do for you. 6 PCl5. How many phosphorus atoms? 6 times 1, 6. How many chlorines? Now, a lot of kids look at this and they think it's carbon and iodine. It's not 2 different atoms, okay? It's chlorine, Cl. 6 times 5, 30, okay? How many atoms total? 36. How many molecules to get to 36 atoms? 6. All right. Now, you really need a lot of practice on that to understand it well. If you take chemistry with me next year, that'll make more sense. But getting a little bit of a grip on it now is good. A couple more questions. You can handle these on your own. We're going to move on to 3.1. All right, 3.1, I'm going to give you one of these. This guy is not an atom. He's a whole molecule. Okay, go down here. We have matching. Now, notice I have these two little arrows here. That's because there's an S on this one. These are almost the same word. Okay. An atom with a charge is an ion, C. All right, moving over to 3.2. This is a beautiful picture of a Bohr's model of the atom. Okay, got to fill in a few words. I'm going to fill in an orbital right here. Okay, down to the bottom. This looks like a 0. It's a symbol that represents a neutron. Whoops, don't cross it off. Circle it. These three are wrong. Taco Ron. Very rare subatomic particle. Yum. Okay, moving on to 3.3. Ooh, I like these. Okay, so it's important for you to realize that positives and negatives cancel each other out. So it says, what's the charge? So if you have one positive and one negative, your charge is neutral. But what if things get more complicated? Let's go down to number 3. If I have this positive cancels that positive, this positive cancels that negative, I should say, sorry, positive, negative. That leaves me with 1, 2, 3, a negative 3 charge, or a 3 negative charge. Now let's go do a really hard one. Let's go do number 9. These get really complicated. Okay, these have neutrons in them as well. You can just ignore the neutrons. So, negative cancels positive, 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 negative cancels positive. Any negatives left? Yes. Negative cancels positive. What are we left with? 1 positive. And I think everything else is taken care of. So we are at positive 1 plus. That is the best way to handle those. And if there's neutrons, just ignore them. They mean nothing. They have no charge. Moving on to 3.4. Okay. Choose the best answer. Let's see. One of these is hard. Which one is it? I guess this one's kind of hard. You have a positive 11, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means we're neutral, which means we're not an ion, and we have 11 protons. This means we are a sodium atom. Okay, that's a pretty good one. Everything else is doable for you. We're going to move on. Oh, we're done with 3.4. We're moving on to 4.1. All right. 4.1, we got some review here. When we see a +1 in brackets around an atom, that means we're an ion. Okay, also, what's the charge on a proton? Protons are positive. Okay, let's go down to matching. Okay, now this is a little detail that's kind of tricky on these that I made. I have sodium written as an ion here, and then I have the word sodium here. And then I say an ion used in the body to help nerves stay calm. I do the same thing with chlorine. So an ion used in the body to help nerves stay calm is M. Okay, M. Because chlorine is actually a deadly gas. 18 is chlorine. So when I'm talking about the deadly gas, I use the name, and when I'm talking about the ion, I use the notation. Okay, so watch out for that. Ooh, drawing. Let me get my colored pencils. Okay, drawing helium. So the first thing I'm going to do to draw it is I'm going to write its symbol as its nucleus. So I'm going to write He. Look, I can actually draw lowercase letters. And then I'm going to draw its charge on its nucleus. So helium has 2 electrons. I know that helium has 2 electrons because it has a 2 as its atomic number. So it has 2 protons. Oh, I just said electrons, didn't I? I know that helium has 2 protons because it has a 2 as its atomic number. So I'm going to put helium 2 plus because I know it has 2 protons because of its atomic number. Now, it doesn't say that it's going to be an ion anywhere, no charge, so I'm going to put 2 electrons on it because it has 2 protons. And so I'm going to go minus, minus, and then I'm going to put a little circle around it like this. And the first shell holds 2 electrons, and so I draw it like this, and voila! There is my neutral helium atom. Now, if we go down a little further, it says to draw magnesium 2 plus. Now I go look at my periodic table. Magnesium has 12 protons. If magnesium has 12 protons and it's a 2 plus, that means it's going to have 10 electrons. So I'm going to draw magnesium's nucleus as its symbol, Mg, and I'm going to draw it as 12 because magnesium has 12 protons. Okay? But now it's only going to have 10 electrons in order to get to 2 plus. So I'm going to draw its first 2 electrons in its first shell, because the first shell holds 2. Ooh, I drew that a little big. Probably should have drawn that a little smaller. Never claimed to be an artist. And now it's going to have the next 8 electrons in its second shell, and that's going to get us to 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's why Mg is 2 plus, because that's how Mg gets a full shell of electrons. All right, now that's probably one of the hardest things I'm going to ask you to do in this whole workbook is draw some atoms. So good luck. All right, 4.3. What is this bad boy? Well, he's got 1 proton and 1 electron, so he's neutral. And who's got 1 proton? Number 1 on the periodic table, hydrogen. So he is a hydrogen atom, C. All right, moving on to 4.4. Chemical and human bonds. An ionic bond is like, well, my metaphor is that it's like dating. I bet that's the word. It's a weak connection where atoms are held together by attraction, but they can separate easily. That sounds like dating. Doom, 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 doom. Dating. All right, we're going to move on to 5.1. Okay, a little review on 5.1. What is the weak bond? What is the strong bond? Covalent bonds are strong. Ionic bonds are weak. All right, moving on. Down here, matching. Let's see, anything difficult I want to tell you about? All right, maybe this one's hard. This is how the numbers are written in a chemical equation in simplest form. I don't know if that was hard. Nothing really looked that difficult to me. Ooh, I like this next page. All right, so these are the reactants and products of the methane demo that you saw in the video. So this big boy's methane, all right, and you can go from there. What's cool is I then show you another chemical reaction. This is the chemical reaction of breathing, okay? You breathe this in, you breathe this out, and you eat this. Now, in order to understand what you're looking at, I kind of give you some options up here. So let me give you one example. You probably can understand. Well, let's take this one. Is this molecule C6H12O6 or is this 6H6O2? Now, you should know this already, but 6H6, that would mean it was 6 molecules. This is not 6 molecules. This is 1 molecule, and it's the molecule C6H12O6. It's sugar. So then it says, you have to color it, but then you have to write it out. So this goes here, C6H12O6. So this is a sugar. And then whatever this is, you're going to have to write it down here. Whatever this is, you write it down here. And whatever this is, you write it down here. So be prepared for that. And what these things are is one of these 2 choices up here in each one of these boxes. And you can figure it out because you're a smart cookie, and it's also what these 3 things are is also what these 3 things are, but there's more of them here. And you have to color. Oh my gosh. When I was a boy, I did not like coloring. But now I think coloring's cool. Moving on, 5.3. I did a bad job. I think I missed this in the notes. So what is this thing? This is a chemical formula. Hopefully you figured that out on your own. Okay, but anytime you write 5H2O or 3C6H12O6 or anything like that, it's called a chemical formula. All right, we're moving on. I think you got it. Whoop! The Big Bang. Oh, this is exciting. I go over the column down here. Okay, this is such a good thing for you to understand, that the universe came into existence. The fact that the universe hasn't always existed, that is huge, man. The fact that we now have scientific evidence to suggest the universe had a beginning, that's huge. That means God exists. Check that out. All right, I'm moving on to 6.1. All right, 6.1, here's some review. Let's go over this one again. Do you remember this process? Positive crosses off negative, positive crosses off negative, positive cancels negative, positive cancels negative, and we're left with a positive. So that's a 1 plus. All right, moving on. Let's go down to the matching. Oh, this is important. So really 2 of these feel like they could be right. The chemical property of being disgusted by water. We could say nonpolar, or we could say hydrophobic. But I have a thing here that says the other way to say nonpolar. So you have to kind of pick the right one here. The chemical property of being disgusted by water is nonpolar. And then the other way to say nonpolar is hydrophobic. Okay, there we go. That's the right way to do that. All right, 6.2. Polar or nonpolar. This is fun. You just do this for every single one. So is grease polar or nonpolar? It's nonpolar. Okay, and you just keep going. And then we come down here, attract or repel. And one of these is kind of unusual for you. Positive and negative. Do they love each other? Do they hate each other? They love each other. Okay, which means do positive and positive like each other? No. Positives don't want to be with other positives. Interesting. Okay, 6.3. Okay, let's see. Pretty straightforward stuff. I'm going to just do the first one. This is an emulsifier. All right, 6.4. I love when I get to talk about God and science together. And that's what happens in these two. Let's see. I kind of talk about how we kind of like learn laws of nature by studying the world, but then we kind of study the laws of God by studying the Bible. And we really wouldn't know what holiness was without just studying the Bible, although it's sort of also written on our hearts. So that's pretty cool. That's what the whole page is about. Check it out. Moving on to 7.1. All right, 7.1, little review here. Which one of these looks difficult? Oxygen looks like a butt. Okay, in case you didn't know. Matching, let's go down there. Equal balance of charge across a molecule means you are non-polar. All right, keep moving. 7.2, a lot of arrows pointing at the same things and asking you basically to remember what it is. So right here, we're pointing at a hydrogen. But then also, this one's really tricky. Maybe you don't know this. 7, I didn't do a great job emphasizing the use of this word. You know, the Earth has a positive and a negative pole, or a magnetic north and south pole. Water has a positive pole and a negative pole. So also the right word to use for this is pole. Okay, 7.3. If ice sank instead of floating, sank. There you go, number 2. And we're off to 8.1. Here we go. All right, 8.1, a little review action. What are those dotted lines? Those are hydrogen bonds. All right, down to matching. Okay, the way to notate a hydroxide ion. That's the one in a base. That's OH minus. Okay, and that's letter H. Okay. This is also really tricky. pH of 7.01 to 14 is an acidic pH. So make sure you use that correctly. I mean, acid feels right, but it's an acidic pH. All right, let's go to 8.2. This is a hydrogen ion, which makes it an acid in a loose definition of the word. H plus is an acid in the loose definition of the word. Okay, keep going. Now, oh, this one's pretty good. You got to look carefully, but you see those little hydrogen ions in there? They're just little hydrogen ions. So that makes this an acid, okay? And then if you look closely in there, you see those hydroxide ions in there? That makes this a base. Now, we're going to have to do the next part together. 8.3. So, if we have a pH of 0, we're an extremely strong acid. So circle the word acid, and now that means we're going to have tons of hydrogen ions. Lots of hydrogen ions, okay? So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I just put 13 in there. Okay, changing plans. I'm changing it to 16. So I put 16 hydrogen ions in for this pH. And as my pH goes closer to 7, I'm going to get closer and closer to having 0 hydrogen ions in my concentration. This is the strongest acid, and a pH of 7, which would be off my paper, is going to have no hydrogen ions. And I haven't drawn the rest of my hydrogen ions in here, but you get the idea that as my hydrogen ion concentration drops, my pH gets to 7. Okay? That's the idea of a strong acid headed towards a weak acid. Now, let's go to the bases, and we get the exact opposite, but it's the same, but it's the opposite with the pH. As my pH drops to 7, my hydroxide ions are going to drop. So, now I'm going to draw, 16. I'm going to draw 16 hydroxide ions. This is going to be really hard. Okay, here are my hydroxide ions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And each one of those needs an ear that is a hydrogen on it. Okay, so I've now got 16 hydroxide ions, and I'm a base, and I have a high pH. As I go down, I'm going to go from 16 hydroxides to 12 hydroxides to 8 hydroxides to 4 hydroxides. And as I get to 7, if I were to get to a pH of 7, I would have no hydroxides, I would have no hydrogens, I would just have water. And that would be a neutral solution. I don't usually switch back to this camera for this video, but that's complicated. I know. I'm trying just to get your brain around the idea that acid has hydrogen ions, base has hydroxide ions. That's pretty advanced chemistry. Now, what you could see is that if I mixed this with this, Mickey Mouse and his missing ear would all come together and would make nice, clean, neutral water every time. So pH of 14 plus a pH of 0, equal amounts, can make a neutral solution. And that brings us over to this. What pH of base do I need to mix with an acid of 2 to make a neutral solution? The answer is, if they're equal amounts, it always needs to equal 14. So 2 plus 12 would neutralize if they're the equal amounts. 0 plus 14 would neutralize if they're equal amounts. And if it always adds up to 14, you're neutral. Okay? And then the last little bit here, there's a special potion of acid inside your stomach. And God knew exactly what he was doing when he made it so that you would turn out just right, right down to the last molecule. Hey, I don't know why you're watching this, but I'm glad you are. Hit that subscribe button if you haven't already. I hope this unit was a blessing for you. You are a blessing to me. Thank you for being a part of this. Peace out, Girl Scouts.